Yeah, we're good. Go ahead.
Hi everyone, good morning. So welcome to the project Wholesale Local Food Benchmarking. My name is Muskan, the graduate fellow for this project and also a computer science graduate at University. So the team includes project advisor, Adisa Exupil, and the three Maxwell Skinner, Neha Hussain, and Nabil Idris, who basically were hands-on on this project. So the agenda for today's presentation is basically first I will give a takeover to explain their work or insights. So we'll have 35 minutes of presentation and then 10 to 15 minutes of QA session later. So the main objective of this project was to develop a process that provides more localized information around price points for local products. Okay, so just to give you a background, the Iowa State Farm, Food and Enterprise Development is frequently asked for benchmarks on pricing of products, both in retail and wholesale spaces. So although there is a data available on USDA and AMS, but there's a limited aggregation of these products for sales at the local level. So there was a need, and there is always a need for additional research to get the prices for wholesale products. As today's pattern is, so many of the producers they are operating in direct to consumer retail spaces. So the main objectives of the projects were first data discovery. So we started with no data. So we investigated a lot of data sources in terms of scraping websites or social media, everything. And then we used Google Trends to identify potential keywords, then narrowing down the exact products as in the top commodities. Okay, the next step was to compare values of USDA versus other data sources prices. Then identify potential aspects of the automation for future data collection. And lastly, how can we apply here AI here, or investigate potential use of AI to identify impacts to local food markets. So on the right, you can see the main outcomes. So we were able to get the top commodities by Google Trends and other parameters. And then we were able to compare the difference between USDA versus local or grocery or food hub price data. Then we created end-to-end automation process for future data collection. And lastly, we were able to build some models to forecast the prices and get the most important variables using weather and economic variables. Now, what you see on this slide is project workflow, or basically how we worked on this project. So step one was data collection. Step two, data exploration using Google Trends and looking at the prices over years. Step three, identifying or finalizing the top commodities for final analysis or to do the research and comparison. Step four, comparing the USDA versus other data sources. Step five, data automation for future data collection. And lastly, step six for forecasting prices. Now, interns will walk you through these steps one by one in more detail.
Hello, my name is Nabil. I'm a senior in data science. So the first step in our process is the data collection process. So after we identified the different retail websites that we want to web scrape from, I'm going to go through a quick run through of what the web scraping process is. So web scraping is the process of gathering information from the internet. So some of the web scraping libraries we use is Beautiful Soup. And the example I'm going to show you is from the Iowa Food Co-op website, which is a static website. So it's easy to use Beautiful Soup on. And some of the things we think about when trying to web scrape is like which web pages have the data we want, and then what are the URLs. Next slide, please. So the first thing we need to identify what the HTML elements that we're trying to pull information out of. And in the example of the first picture on the right is the div class, and you can see the product information like snack size, summer apples, and the price. And we need to pull that information out. So first we would get the information from the HTTP request from the URL. And then we would create a data frame of, the categories that we want, like category name, item, producer, unit, and price. And then we would, next slide, please. And then we would parse this HTML. Here, the example, we use the for loop and then combine that with our find all function in Beautiful Soup to pull all this information out. And then we would transform them into a pandas data frame for easier analysis for later on. And then we'll save this into a CSV file. Thank you.
Hello, my name is Neha. I am a junior at Clemson University studying computer science and economics. So the next way that we collected data was through field work. We actually went to farmers markets in Des Moines and Ames and took pictures of prices that we saw, and also had conversations with the farmers, asking them how they determine their prices and their products. Their responses further confirmed why this research is so necessary. Most farmers' responses said that they just look at what other people are pricing, or they try to use USDA data, but the USDA data is not reflected of the local economy. At these farmers markets, we took pictures of the prices and we manually put them into an Excel sheet. We can go on to the next slide. And our last method of data collection was cold calling and emails. We would cold call and email these producers on their wholesale products for local prices. We got some valuable insights, such as farmers usually review the prices once or twice a year. It doesn't change on like a monthly basis. And with this data collection method, although we got some useful data, it was very sporadic, as one producer would have like 3 out of the 5 commodities that we were looking for, while another one would only have 1. And so it wasn't very comprehensive. And also, we learned that many farmers don't keep historical price records. At most, they'll have prices for 1 to 2 years back, but not enough needed to create very comprehensive and deep AI and machine learning. So we can go on to the next slide. So here is a diagram of all the data collection methods that we use. Like Nabil already described, we use web scraping for websites like Iowa Food Co-op. We did some field work. We went to farmers market and we manually extracted these prices, and we cold call and emailed producers all to get local food prices and our raw data.
Hi, my name is Maxwell Skinner. I am a sophomore in data science at ISU. For our data exploration process, we used Google Trends pretty heavily. We looked at Google hits by search keywords for products over multiple years. So in general, Google Trends is a data observation tool that can look at the popularity of certain keywords. So how we used it was we looked at the keywords of certain agricultural commodities and looked at certain patterns of when those commodities are usually popular, or how popular they are in general. So as you can see in the right-hand chart, for some agricultural commodities and those keywords, there's a very strong like seasonality to them. Something like apples or cucumbers or rhubarb, like over the course of multiple years, there's a very strong pattern between its interest, And on the chart on the left-hand side, we see like the year 2021. So we did some analysis over what agricultural commodities are the most popular over a single year. So as you can see on the left-hand column, like peppers in 2021 was the most popular for that year. And then on the bottom left-hand corner, we looked up individual keywords to see to support our hypothesis of like, are these patterns pretty consistent over multiple years? Can we expect this to happen more than once? And they do. So for something like strawberries, it is a very extremely strong pattern of its popularity and its seasonality over the course of multiple years. And on the next slide, so in addition to for the data exploration process, we also looked at the apple price trend over multiple years. So on the top left-hand chart, it's a general box plot of the price of apples from 2016 to 2021. We were not only looking at just like where the kind of mean or average price of apples was over the course of multiple years, we were also looking at the variability of those prices, like what was the difference between like the lowest and highest price and stuff like that. And that was very important because when we used that information later on for our machine learning process. So the right-hand column is we also looked at the difference between organic and non-organic apple prices. And not only for apple prices, but for multiple agricultural commodities, we see that there is a massive difference between the markup between organic and non-organic products. So we also found a strong correlation between Google search hits and apple prices, and also other agricultural commodities. The bottom chart is just an example of that. So the bar chart is the Google hits, and the line chart is the price of the commodity. So when the Google search trend is down, the price is usually up. And we see that pattern happen reoccurring over the course of multiple years. And on the next slide, we do see that supported with other agricultural commodities. So for something like strawberries, we see a negative correlation between search trends and prices. But for a keyword like peppers, we realized each commodity is different with its behavior. There isn't one set, there's one set seasonality, and they're not all, they don't all follow uniform patterns. Also, for something like peppers or dairy products or those kinds of keywords, we found that we have to tailor our search to be very specific to those certain keywords, because if the keyword is not specific enough, we couldn't really find a pattern, because people could search up those keywords for any number of reasons, not just because related to specific agricultural reasons. And then on the next slide, so we used from the data collection process, we gathered all of our data and we selected the top products by Google Trends, stuff like including apples, corn, cucumbers, strawberries, by hits. And we used that data as well as the data we scraped, and we found that we had to also filter out those products by area and acres for Iowa. So basically determining what agricultural products pertain the most to Iowa farmers, what is grown the most in Iowa, what local foods are grown the most in Iowa, and stuff like that. And then we tailored that list further to only choose one variety of an agricultural product. For example, for apples, we only chose Red Delicious, or for tomatoes, we only chose Heirloom. And we also narrowed down the unit of measurement for that data item, because for something like peppers, from multiple data sources, they were measured in 5 or 6 different ways. Each 1 pound, 3 pound, a box of them. There's multiple ways to measure each agricultural commodity. So we made sure to narrow it down to just one single unit. So our list of final products was Red Delicious apples, strawberries, pears, Heirloom tomatoes, and green peppers.
Okay, so now that we have our commodities and we have our raw data, how do we compare the prices from multiple sources, since we got these from multiple sources? So we decided the best way to do this was to divide them into different channels. So in the first channel, we have the direct-to-consumer channel, which is just producer to consumer. An example of this would be the Ames Farmers Market. The next channel we have is wholesale channel. It's producer and goes to a wholesaler or a distributor. An example of this would be a producer selling to Cisco or ISU Dining. And then we have our retail channel, which is producer, then it goes to a wholesaler sometimes, and then it goes to retail, and then it goes to the consumer. An example of this would be Hy-Vee or the Wheatfield Co-op. Now, this diagram, we've made this diagram for all 5 of our commodities. I'm gonna go over this one right here, the tomato one. And these are all average prices from 2021. And we took the average because we had like limited data. So on the left-hand side, we have the grower price, which is what the farmer keeps, share that the farmer keeps. And then we have 3 different channels it can go from the grower price. So in the yellow box right here, the direct-to-consumer channel, we have grower price going directly to direct-to-consumer price. So this is like going to the farmer's markets. And then you can go from grower price to wholesale. And in wholesale, you have two different kinds of wholesale. You have a national source and you have a local source. So a national source would be like Cisco. And a wholesale price for a local source would be like to ISU Dining or Global Greens. Now you can kind of see the price markup here. We go from 0.057 cents per pound to 2.60 per pound for the wholesale price, and 0.57 per pound to 0.83 per pound for ISU Dining. And then from wholesale, you can go to retail. Again, it can be national or local. So on the national level, you have Walmart, or in the local, we have Wheatsville Co-op. The interesting thing here to see is that the grower price for tomatoes is really small, but the retail price is really high. And one reason, but the one with the highest markup is actually the farmer's market. And we have one probable explanation for this, is that when you go to a farmer's market, you're kind of expecting the most fresh products, since it doesn't have to go through the packaging and the transportation. And also farmers follow best practices methods like integrated pest management. Going through these diagrams, what we really want to highlight is the disparity between prices and how much they fluctuate. Now, in this chart right here, we have a price markup percentage table. So these are the average markup from the grower price. So the grower price is our base price. And it shows the percentage increase when you go through the supply chain. And now you can look over here, we have like 600% from Wheatsville Co-op. And it shows like how much more do you pay when you buy wholesale versus retail versus like direct to consumer. And if you look at ISU Dining has the lowest markup. One caveat here is that it's not good to make an overarching statement and about like the price market when it comes to grocery stores, just because commodities vary so much in their prices and they fluctuate a lot. We can go on to the next slide. All right, so here you have two interesting graphs. These are price markup trends. So in the first one, we have the blue line is USDA retail price, and then the yellow line is USDA grower price. This is apple price over trends. Now, as you can see, as time goes on, the space, the gap between the orange line and the blue line is increasing, showing you the difference between retail price and grower prices going, and how and where your money going. So, and overall, the trend is that farmers are getting less share than what they used to. And then now let's look on the bottom graph. This is Apple retail price trend for 2021. And we have three lines. The green one is USDA Midwest, the yellow one is Walmart, and the orange one is Iowa Food Co-op. Now with this one, I can kind of show you that when COVID happened, Walmart prices actually went up versus the Iowa Food Co-op and USDA Midwest prices went down. So those two actually reflected the downturn of the economy versus Walmart, it just kept going up. So you can just see it's a further explanation why this research is so important, because Walmart didn't adjust when the national economy took a hit, but the Iowa Food Co-op and the USDA Midwest did. So these kind of events affect a local economy way more than it does national or at the national scale. Now, the next series of graphs, we did this for all 5 commodities too, is just demonstrating the percent market share for farmers versus retail, like farmers price versus retail price. So on this one on the left, you can see when you buy direct to consumer, the farmer gets 85 cents and less to spend on marketing, which is 15 cents, versus if you go through the retail route, like a grocery store, farmer gets a lot less of that share at 43 cents versus 57 cents spent on marketing. So a lot less is spent on advertising when you buy direct to consumer versus if you buy retail. A lot of what you're paying for is going towards marketing, and marketing includes like transportation, packaging, etc.
So going back to the data collection process, we decided that we needed also to look at historical prices from websites. So we looked at the Wayback Machine, which is a digital archive of the World Wide Web. So they take snapshots of websites, then they'll save them. And one of the challenges of using this website is not all website data is captured. So as you can see an example at the bottom of Iowa Food Co-op versus Hy-Vee, the data captures are different. For Iowa Food Co-op, you only have for 2021 and 2022 versus Hy-Vee goes all the way back to the year 2000. And this does not work with all websites. So for example, when you try to go to Hy-Vee.com using the Wayback Machine, all information, the website information might not load. Next slide, please. So we decide to go with to create a data automation process to build a database of historical website. And one of the ways is to scrape using Python and Postman API. So the Postman API is like a testing platform. So you're able to replicate the API request from the website itself. And to do this, you'll navigate to farmart.com page. And then if you go to the Chrome developer tools, you can select the Fetch HR tab. And if you do a refresh, step 3, you'll see all these requests that will show up. And you want to find the name, it's called something like browser affinity, which has all the JSON information of the product info. And you want to copy this and copy as a curl request. Next slide, please. And you'll go to postman.com. This is a free service to use. And after you sign up, you'll go to the workspace and you'll import that curl request into the workspace. And you'll see that you can copy the Python request from the code snippet in step 6. And then you want to copy this and paste it into your code editor. Next slide. And this is a screenshot of what the request looked like. And at the bottom, you'll see that that is JSON request that the information is in. So you don't actually have to parse HTML, which is really convenient. The only downside is it might not work on a static website. For example, like it will not work on like Iowa Food Co-op. And the code at the bottom is the automation process that you've implemented that would run every 1 week. And then we will save this information for future analysis.
So for the final step of our project, we incorporated AI into local food benchmarking. So we thought the best way to do that would be to predict the average price of a commodity. So our objective was to utilize machine learning models to predict future commodity prices based on certain indicators. The indicators we used were historical USDA retail price data of apples and tomatoes in the Midwest region, historical precipitation and temperature data from ISU and just the Iowa area, drought data in Story County, Iowa, the 10-year US interest rate, gold bullion historical price, crude oil futures, and the Bloomberg Commodity Index. Just a real quick context for some of these indicators. For USDA retail price, the USDA has a very in-depth historical prices of retail prices of almost every commodity. So we used USDA Midwest data because that was the best way to get historical data to train a model on. With a lack of historical local food prices right now, we used USDA instead. And then for things like 10-year US interest rate, gold bullion, historical price, and stuff like that, when we were talking to farmers and they said, like, we don't really decide the prices ourselves, we look at like market conditions or just in general what other people are doing around us, we figured, okay, well, outside market conditions would have a bigger impact than what individual farmers are pricing their fruits and vegetables on. So that's why we used stuff like crude oil futures, and the Bloomberg Commodity Index is just a index averaging the price of all agricultural commodities. So that was a great way to get a general trend of where fruit and vegetable prices are in general. So then on the next slide, how we chose the machine learning model. We chose We chose a linear regression model because it is the best way to estimate the relationship between multiple quantitative variables. It's very nice. This is the best model to use when you're trying to find a continuous value. So something like average price, like something that fluctuates over time. Linear regression is one of the best models to do that. It's a simple model, and the modeling speed is fast, and it doesn't require a complicated calculation. So we used linear regression, but we used as well a Python library called XGBoost, which is also a linear regression model, but it uses extreme gradient boosting, and it's efficient and effective implementation of the gradient boosting algorithm. It's designed to be both computationally efficient and highly effective. How XGBoost works versus other more simpler models is it operates on decision trees, models that construct a graph that examines the input under various if statements, like vertices in the graph. And then whether the if condition is satisfied, it influences the next if condition and then eventual prediction. The algorithm continuously adds more and more if conditions to the decision tree to build a stronger model. So there are multiple stems of a tree, and those stems create a ton of different branches, and they are continually learning over and over off of each other to get a more accurate model. And the summation of those trees is what we get for our final result. So then on the next slide, our observed metrics. So to find out how well our model did, we used mean absolute error, mean squared error, root mean squared error, and R squared. Some of these metrics are pretty confusing for most people that aren't familiar with machine learning. So I'll just explain mean absolute error, because that pertains the most to our project. So mean absolute error is basically, in the context of this model, it's how many cents it was off compared to the actual price. So we compared the metric performances of our apple model and our tomato model. And under MAE, that decimal point is about how many cents on average our model was off compared to the actual price. So for the MAE of the apple model for linear regression, it was about almost 17 cents off on average. And then for XGBoost, it was just about 16 cents off on average from the actual price. And it's similar results for the tomato, with 13 cents off for linear regression and about 13, almost 14 cents off for XGBoost. So on our next slide, this is our plot of feature importance for both models. So feature importance essentially means in those decision trees that the model used, what features were the most prominent in all of those trees? What features were used the most? What had the most value? What had the most weight in influencing and accurately predicting the price? So a good example, the first four would be the average temperature of Iowa, the 10-year US interest rate, the Bloomberg Commodity Index, and our local Iowa drought weather data. As you can see, average temperature and the 10-year US interest rate has a massive lead over anything else. And we kind of figured that it would be the case with some of these outside economic indicators, because while weather conditions can influence the price of a commodity, since farmers still aren't actually deciding the price of that commodity themselves, and we are looking at retail prices, of course, outside economic indicators like the US interest rate and how the overall economy is doing in general would be a better indicator of how those prices are being influenced than the individual weather data or the individual what the farmer's pricing it at. So on our next slide, so we were able to forecast future prices with this model using just historical stock prices, historical weather data, and drought data. Our model can predict the retail price of apples and tomatoes with only about a small error, 13 to 17 cent difference on average. This model can be used for future forecasting of prices of multiple agricultural commodities. This model is highly versatile, exchanging historical USDA retail price data with local food retail price data. We could reasonably predict the prices of foods on the local level in the possible future. So in the future, if we were to have a database of historical local food prices, we could easily use this exact model to predict not just Midwest retail price data, but local food prices as well. So the two graphics you're seeing is how well are these two graphics are basically how well our model did versus the actual price. So for both models, the orange line is what our model predicted, and the blue line is what the actual price was. So it still needs some more fine tuning in the future, but our model was able to, in general, predict the general up and down behavior of what those prices were going to be. So with further parameter tuning and the adding of more indicators, we can bring this margin of error continually lower. One key prospect in the future is to add weather data specific to where that commodity was grown. For example, adding historical weather data from Washington or New York to find the correlation in how weather from those producer regions can directly impact the price of that commodity to the consumer. So yeah, on to the next slide.
So yeah, one of the things that was a big challenge in this project was the data collection process. So moving forward, this is a diagram of what we think could be the next steps. So we'll continue with the web scraping process, and then to add to going out to the farmers markets and gathering pictures, and then we would add a computer vision asset to this, so we would be able to extract prices. And then in terms of producers, we'll continue to be reaching out to them, cold calling, email, and then provide them with a tool that they can enter in this product information and send it back to us on a monthly basis. And then we will put all this into a database where we can, write scripts to clean and then extract the data we need, and then to do further analysis on it. Thank you.
So I think that was our project, and now we are open to questions.
Hey, Sean here. Nice work on that. It's a cool project and a lot of great work, great visuals, great presentation. More a comment than a question that, your last slides there on prediction, that's really coming along quite nicely for a first pass. And I especially, think, given the qualification that a big part of your prediction is around a huge outlier period with COVID and the disruptions in supply and changes in whole systems. And so, I think as that, if the project continues and you get farther from COVID and that the outlier phenomenon, if you can go backward, get a little more historical, my guess is your prediction model is just going to get tighter and tighter. But, good job on getting that fairly impressive given such a weird time that you're trying to lay a prediction up. So well done.
Thank you. So one more thing to add here. So we used intrastate and commodity index because whenever there is some condition or some calamity, you don't see the immediate effect. So you will see the drop in prices after maybe 2 or 3 months. Okay, so that was the main reason for the prediction, because we have time, to tell the producer, okay, there can be a drop in prices or there can be some limit or something like that.
Hey, one more, just a quick question then. Early on, you had a slide that showed this rising gap between producers' share and then I think retailer share. What are your thoughts on that? What's the action plan? Where do you go with that data?
So that data basically showed the more right now, more money is spent on the marketing share, as in transportation or packaging. That data says that. So I think, so from that data, our main point was to, spend more money or buy from the farmers market.
Farmers market's the answer. We all knew it at the beginning. Dang it.
Because, so one thing is when you buy from a Hy-Vee or a Walmart store, sometimes their fruits or vegetables are not fresh. One thing is, and then, so they spend a lot of money on packaging and everything. Yeah. So that was the point we wanted to highlight.
It made me think about the relationship between how easily perishable various commodities are to their price. Like strawberries is one that always strikes me. It's, you know, the amount of time strawberries look good is pretty limited versus apples, say. Did you see any relationships with regard to pricing related to that?
Yes. So from the farmers market, the strawberries, the price for strawberries were really high because it was more fresh. So, and from the other stores, the price maybe from like High School Walmart, the price was a little low compared to the farmers market, but it was not that fresh.
I can also add on, but what you're saying, like strawberries definitely had a lot more fluctuation between prices, maybe due because they're like such a small amount of time that are good before they start going bad, versus apples, they can like stay out longer and not go bad as fast. So apples didn't have as much fluctuation in prices as you saw with apples. But we're going to need to do further analysis on that to confirm these relationships.
I would just think it would, you know, be an impact from a standpoint of what they would expect for waste. You know, if they don't get sold within a day or two, they're done, versus, you know, apples you can keep longer.
Yeah, let me jump in here. Jane, that's great questions. It's actually one of our assumption at the beginning of the project. I assume that, well, even more than strawberries, I always have issue with raspberries. So whenever we buy like berries back home, right? Strawberries is kind of medium. Blueberries will live a little bit longer, but raspberries, well, the moldy like so quick. So we at the beginning of the project, we expect that the shelf life or how perishable of this produce will definitely impact. But unfortunately, we didn't have enough price point for different market, enough for some of those produce. So, well, we did collect like a long list of produce, and we also trying to get scrape data from like Walmart, Hy-Vee, and other places. Also, co-op, we still food co-ops. And if we have like multiple price point of some of those produce, then we can put into a model and we can understand it better. So yeah, and we didn't have enough data for some of those, so that's why it's a little bit too bad. But of course, in futures, then if we have more price point for those, then it can be plugged into the models or in the process that we have, and then we can expand the list of this produce, and that will definitely show a lot of other things.
I have a question. I guess just reflecting back on the project, what was the most like surprising or like significant thing that you found? So maybe something you weren't expecting, or that had most influence on the end results.
So first thing is, for me, I did not expect a huge markup. I mean, the difference in the prices. So that was the part. So we were really surprised to see, okay, we can get at a very low price from here, and then and from a different data source. So that was one point. And so in terms of challenges, we saw that so every fruit, every vegetable has multiple varieties, multiple units. So, and the price vary a lot by variety. So, so basically, this was something we had to do a lot of work on. I think I lost your question.
So, well, that's good question. Let me go next before go to other team member. I think that's great, and well, a lot of things that is surprised me, especially like price point of each different market and different outlet. So I went scout for price in farmers market and like Wheatfield Food Co-op, and those are three nice people. They like give me like the price list that I pay for farmers, and then well you can see the price that they're selling. And sometimes some of those produce it's well, I think we all have some expectation that co-op will be more expensive, right? But sometimes it's not. And surprisingly, sometimes the price in like Walmart or Hy-Vee or some certain produce, they shoot up, and people just have expectation that it's usually like it's cheaper than farmers market or food co-op. Sometimes it's not as well. So yeah, and I think since no one really collect all the price from everywhere and make a public like a price chart or updated price, then I don't think people realize that which one is more cheaper and expensive at all. They just go with the instinct that okay, I think this is, we go to Walmart and I think that's we paying less, but turn out that that's usually a lot of time it's not the case at all. Yeah, that's quite a big surprise for me.
Well, I wanna, Michael, you can expand on this, but I was surprised to learn with machine learning, like you have all these different factors that you use to train your model that you wouldn't necessarily think of, like the Bloomberg commodity index or all the other economic factors to train your model to get like an accurate model. So I thought that was very surprising.
I mean, I was surprised to learn that like farmers don't really even like necessarily know exactly how much they're going to price their commodity at unless they compare it to others. I just thought like it was a set thing, like everyone just knew what the price of, every farmer just knew how much they should sell their like carrots or vegetables for, but they don't really, like they change it every single year, and they're only comparing it off of the farmer next to them, and then that farmer's comparing it to the farmer next to them. It's like it's this very like decentralized system. So it was great to be able to have like economic indicators like this Bloomberg commodity index that does have a mass general measurement of what those fruits and vegetables are priced at.
I would disagree. I remember asking farmers, like, do you have a set formula they use to price these things? And just like Michael said, they like just look around, compare it to what they have with each other. But then that just further confirms why this project was so necessary, because there really is no local benchmark, but we've created a nice foundation for this project to be built on in the future.
And I think this is a very interesting problem statement, and a lot can be done in this space in terms of analysis and predictions, everything.
I have to chime in too. It's been really exciting and fun to work with the team over the course of the summer. And I think we gave you all a tough question to answer. And then we added these different scales of wholesale and retail, and please look at local and also a global market. And so I think you did a great job of digging through some of those nuances. And it's also rewarding to hear your comments back on like, yeah, this was tricky. And then this is it's a complex world of working in local food systems to figure out those market spaces, and also seeing in these price differences the values that we place then on where and how we spend our money. So thank you for all of your work. I'm really excited to see where this goes next and how it can be a useful tool for our farmers and food businesses, as well as just to showcase the different trends that we see in different spaces. So thanks all for everything you've done this summer.
Courtney, would you like to respond to Sean's question in chat?
Yeah, Sean, so one of the reasons we suggested this project was because we have been getting questions about different price points. And I'm not sure if it's Extension's role or if there's other opportunities for organizations and businesses. I think right now in Iowa, we have a lot of great programs like Practical Farmers of Iowa and networks of like sharing that sort of data. But what we're finding at least is that folks aren't being transparent necessarily in their price points, or really doing that deep dive into other expenses and those components that might be influencing the price setting. And so I know others are doing research, but that's been a gap that we've seen. And I'm saying we as like farm, food, and enterprise development and people working like very hands-on with small farms. But yeah, I think it's a good question.
There was a question on if farmers were compensated for their time of reporting the prices, and they were not compensated in this study. And I don't foresee that being a model that would be pursued to compensate them for that, because it's being built for their service to begin with. So I wouldn't foresee that being a future feature of this.
So I was thinking maybe we can, to get the data from the producers, we can build a product where we can tell them to enter the price. And then if they enter, then only they can see the prices from multiple data sources and they can compare it. So in this way, they will get the information and we will also get the information. So it's like a win-win for both of us.
I am typing out a long-winded response to the compensation too, so I'll unmute and share an idea. I think compensation would be interesting to pursue as like an incentive to share, and also agree though with Chris's comment about like the goal is that this is a tool for farmers and food businesses. That being said, an idea might be to have more farmers as a reviewer and be a part of kind of a cohort or committee to help guide the project in the future too, for buy-in. I think this project came up pretty quickly, and while I and others have passion in this space, I'm not a farmer. And so I think having that like firsthand knowledge in addition to the folks you all connected with and like going to farmers markets, I think that would be really valuable to consider for next time.
So I would really thank you for your time, Courtney, for your comments and your guidance throughout this project. This really helped because none of us was from the agricultural background. And so, so we got a lot of knowledge from you, from the sessions we had with you. Thank you.
All right, if there's no more questions, I'll stop the recording.
And thank you, everybody,